All right, this video is going to cover Module 2 Homework 1 notes. We're talking about graphing equations. So with our graph, we have this symbol. We're going to label the quadrants, the x-axis, the y-axis, and the origin. So here's our graph. This whole graph together is called the Cartesian plane. It's called a Cartesian plane. It's this whole thing together. Left and right, we have what's called our x-axis. Up and down, we have what's called our y-axis. Where these two things meet in the middle, this point right here is our origin. So our x-axis tells us how much we're moving left and right. Our y-axis tells us how much we're moving up and down. So this will give us our x value and our y value for our ordered pair. Or our coordinates. Sometimes it's called coordinates. The x value and our y value. So left and right will give us our x values, positives over here, negatives over here. Up and down will give you our y values, positives are up, negatives are down. So our origin is our starting point. So that would be 0 for x. That's like our starting point. We're not moving left or right any. And then our y-axis value, our y value is going to be 0 as well. So our origin is going to be the ordered pair 0, 0. Notice it's in alphabetical order. So x comes before y in the alphabet. So in our coordinates, x comes before y as well. So then notice that your x-axis and your y-axis cut your Cartesian plane into 4 quadrants. So this would be quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. So notice we're using Roman numerals. So this would be 1, 2, 3, 4. And also notice it goes counterclockwise. So because it goes counterclockwise, that's our parts of our graph. So now let's actually go and graph one. So let's plot some points. So we're going to plot 4, -1, 1, 2, -2, 4, 0, 3, and -3, 0. So left and right would be our x-axis. Up and down is going to be our y-axis. So this first ordered pair, 4, -1, is going to go as x of 4 and y of -1. So on our x-axis, we're going to go over to positive 4. So right here. On our y-axis, we're going to go down to -1. So where these two values meet will give us this point. So over positive 4, down -1. So 4, -1, that point. Our next one's 1, 2. So x is 1, y is 2. So on our x-axis, we're going to go over to positive 1. On our y-axis, we're going to go up to positive 2. Where these two things meet, boom, there's our point. 1, 2. Oops. All right, next one. -2, 4. So x is -2, y is positive 4. So over -2 on our x-axis, up to positive 4 on our y-axis, where these two things meet, boom. -2, 4. Almost done. 2 more. 0, 3. X is 0, y is 3. So going over 0 on our x-axis. So we're going to stay right in the middle. And then we're going to go up to 3 on our y-axis. So 0, 3. Over -3 on our x-axis, up or down 0. So there is our last point, -3, 0. Remember, x is -3, y is 0. So that's plotting some points. So notice, always check the scale. And what that means is notice how each line is 1. So it goes 1, 2, 3, 4, 5. We're counting by 1s. Same thing for our y-axis, 1, 2, 3, 4, 5. We could count by 2s. It would be 2, 4, 6, 8. We can count by 10s, 10, 20, 30, 40, whatever the case may be. But make sure that is your scale. So always check your scale to see what your the graph is moving up by. All right, so is the equation linear? We talked about solving linear equations back in Module 1, Homework 1. So we're talking about what that word linear means. So linear means a straight line. So in a linear equation of two variables is an equation that can be written as ax plus by equals c, where a, b, and c are real numbers with no fractions, and a and b are both not zero. If they were both zero, it would just cancel out and have nothing. So notice this ax plus by equals c. This is super important because this is our standard form. This is our standard form that we're going to use a lot. So notice with ax plus by equals c, there's no radicals, like there's no square roots, there's no absolute values. It's just x and y. X is just to the first power. It's not like x squared, x cubed, nothing like that. They're just x to the first power. Same thing with y. Y is to the first power. A lot of times we don't have to write those first powers because it's understood that it's x to the first power. It's just x. Y to the first power, just y. So let's use this on the next page. So it says, in this example, is the equation linear? Can I write it in the form ax plus by equals c, which is our standard form? So, for example, A, 10x plus 10y equals negative 10. Looks pretty similar to ax plus by equals c, x to the first power, y to the first power, everything's good. So yes, it is linear. B, y equals the absolute value of x minus 2. Well, now I have these absolute value bars. So the absolute value bars aren't in our standard form, and I can't get rid of them. So that means no, this is not linear. If I were to graph it, it would not be a straight line. Next one, let me just change the way this looks. C, 7x minus 9. Let me put you up here because of absolute values. All right, over here, C. 7x minus 9y cubed equals negative 11. So here I have this cubed. I have y to the third power. I can't do anything to get rid of it. It's not part of our standard form. So that means whenever I graph this, it's not going to be a straight line. No, it's not linear because of the exponent of 3, and it's on our variable. So it's on y, so that's why I can't get rid of it. All right, so last but not least, D is 7 over x minus 9 over y equals negative 11. Here, my variables are in the denominator. That's not how it is in standard form. I can't do anything to get rid of that. So no, this is not going to be linear either. Because our variables, sorry, my email's going crazy, are in the denominator. So no, not linear because the variables are in the denominator. So that's what graphing would look like. We can just look at the equation and say, okay, is it going to be a straight line or not? So let's use that to now graph some equations. So this first example, it says for the equation y equals x divided by 5 minus 2. Just by looking at it, is this linear? Yeah, I mean, I have a fraction, but my variable's in the top, not in the bottom. So whenever I graph this, it's still y to the first power, x to the first power. So this is going to be linear. So yes, whenever I graph it, it's linear. So it's going to be a straight line. So I can keep that in the back of my mind. So whenever I graph it, I know what it's going to look like. So it says complete the table. It gives us x is negative 10, x is 0, and x is 5. And then we're going to use that to graph the equation over here. Let me swim out just a little bit. Oops. All right, so it's telling us to plug in negative 10 for x. So y equals x over 5 minus 2, plugging in negative 10 for x. So y equals negative 10 over 5 minus 2. Negative 10 divided by 5 would give us negative 2. Negative 2 minus 2 would give us negative 4. Let me show you real quick on the calculator too. So here's the calculator that we need for this class. Here's turning it on and off. Here's clearing it. Here's all of our numbers. Here's our operation. So add, subtract, multiply, divide. Notice this is subtracting. This down here is our negative. So if you use the wrong one, whether it's negative or subtraction, it'll say error. And then here's your parentheses if you need it. We'll talk about other stuff as we get there. But if we did something like negative 10, use the negative down here, divided by 5 equals negative 2. Negative 2 minus 2. So because I'm minusing, because I'm subtracting, I'm going to use that symbol. And that would give us negative 4. So our x value is negative 10. Our y value is negative 4. So x is negative 10, y is negative 4. We'll graph it in a second. Let's plug in 0 for x. So y equals 0 divided by 5 minus 2. 0 divided by 5 is 0. 0 minus 2 is negative 2. Again, if you need your calculator, use it. So x is 0, y is negative 2. Next, let's plug in 5 for x. So y equals 5 over 5 minus 2. 5 divided by 5 is 1. 1 minus 2 would give us negative 1. So our x value is positive 5. Our y value is negative 1. So boom, I have 3 points. I can now plot these 3 points, connect the dots. I know it's going to be a straight line, and we're done. So over here on our graph, x is up left and right, y is up and down. Our x value for our first point is negative 10, negative 4. So x is negative 10 going over to negative 10. And then going down to negative 4, where these two things meet. There's my first point. Next, I have 0, negative 2, so going over 0, down 2. Then 5, negative 1, over to 5, down to negative 1. So connecting the dots. There's our graph. Done. Let's do another one. This example says, for the given graph, what is the value of y when x is 4? So it's telling us x is 4. What's y? So it kind of is going to look like this. X is 4, but what is y? So let's look at our x-axis left and right, y values up and down. When x is 4, let's see, here's our graph. Here's this point. What is this y value? Negative 5. Negative 5. So this will be the ordered pair for negative 5. So our y value is negative 5. Done. All right, let's keep rolling. Last page for this section. It says, for the equation y equals x squared minus 5, complete the table and then use it to graph the equation. I have y equals x squared minus 5. Now, just looking at this, I have x squared. So because of that squared, because of that exponent of 2 on my variable, I notice by looking at this, this is not going to be linear. So it's not going to be a straight line whenever I graph it. Just keep that in the back of your mind. It asks us to plug in negative 1 for x, 0 for x, and positive 1 for x. So let's do it. So y equals x, which is negative 1, squared minus 5. Notice it's in parentheses. So I have y equals negative 1 squared. So negative 1 times negative 1 is positive 1. Positive minus 5 will give us negative 4. So this will give us the ordered pair negative 1, negative 4. So x is negative 1, y is negative 4. On your calculator, I just want to show you real quick how you can plug it in. It's super important to use the parentheses here. We'll talk about that more later in module 2. But I want to say it's like homework 5. But make sure to put it in parentheses. So right here, my parentheses. So in parentheses, negative. So we're going to use our negative button down here. So negative 1, closing my parentheses, squared, here's our squared next to that 7, minus 5 equals -4, done. All right, so now plug in 0 for x. So y equals 0 squared minus 5. 0 squared, 0 times 0 is 0. 0 minus 5 is -5. So x is 0, y is -5. Next one, x is 1. So we have y equals x, which is 1 squared, minus 5. 1 squared, 1 times 1 is 1. 1 minus 5 would give us -4. So again, we have the ordered pair, oops, +1, -4. X is 1, y is -4. All right, so we have our 3 points. Let's plot these 3 points, connect the dots, we're done. So over here, our x-axis goes left and right, the y-axis goes up and down. Our first point is -1, -4. So when x is -1, we're going to go down to -4. Here's our first point. Next is 0, -5. So x is 0, down to -5 on our y-axis. Over 1 for our x-axis, down to -4 for our y value. And there's our 3 points. It's not a straight line. We knew it's not going to be a straight line. It's x squared, which we'll talk about more in college algebra, but I know whenever I connect the dots, it's going to be a U-shaped. As long as you connect the dots, you're good to go. The homework will connect it for you in the right shape. But there we go. So let's do our last example. The last example has an absolute value. So for the equation, y equals -5 times the absolute value of x. Remember, absolute value means whatever's inside those vertical bars is going to become positive. So I know just that by looking at it, there's absolute value. So I know it's not going to be a straight line. It's not going to be linear. So I just know that in the back of my mind. It asks us to plug in -1, 0, and 1 for x. So y equals -5 times the absolute value of -1. -1 is x. So we have y equals -5 times the absolute value of 1. The absolute value of 1 means whatever's inside the absolute value bars become positive. So -1 becomes +1. So we have y equals -5 times 1, which is -5. So x is -1, y is -5. So let's finish here. So y equals, I'm getting ahead of myself, -5 times the absolute value of x. In this case, x is 0. So -5 times the absolute value of 0. So -5, the absolute value of 0 is just 0, stays the same. Y equals -5 times 0 is 0. So our x value is 0, our y value is 0. Last one, x is 1. So y equals -5 times the absolute value of 1. Y equals -5 times the absolute value of 1 is just 1. -5 times 1 is just -5. So we have the ordered pair -5, 1. Nope, I wrote that backwards, sorry. X is 1, y is -5. There we go. All right, so our graph over here, x goes left and right, y goes up and down. So on our x value, we have -1, -5. So over -1 on our x-axis, down to -5 on our y-axis. There's our point. 0, 0, so our origin. And then 1, -5. So over +1 on our x-axis, down to -1 on our y-axis. This is an absolute value. So I know that it's going to be a V shape. Your calculator, or I'm sorry, your computer for the homework will do that V shape for you, so don't worry about memorizing that. We're going to talk about that more next semester in college algebra. So as long as you plot the correct points, connect the dots, you're good to go. There we go. And that is all of Module 2, Homework 1 notes. If you have any questions, please let me know. If not, go ahead and work on your Module 2, Homework 1 assignment. And thank you for watching.